This is SpaceTime, Series 22, Episode 85. Coming up on SpaceTime, NASA's Mars 2020 rover to search the red planet for microscopic fossils. ESA's plans for a new Comet Interceptor mission. And speaking of plans, how's about a new mission to orbit Pluto? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has announced that its Mars 2020 rover will land on the red planet's JEZERO crater. The landing site's been selected as it's considered the best place on the planet to look for signs of microscopic fossils and ancient life. Mars 2020 will launch aboard an Atlas V rocket from Launch Complex 41 at the Cape Canaveral Air Force Base in Florida on July the 17th next year, landing in JEZERO crater on February the 18th, 2021. The rover is based on the same design and technology used for the Mars Curiosity rover, which is exploring Gale Crater. Mars 2020 will use a mixture of proven and new scientific instruments and will also carry a small helicopter drone. A report in the journal Icarus claims JEZERO was chosen because it contains deposits of carbonate minerals along the inner rim of the crater, which was once the site of a lake more than 3.5 billion years ago. On Earth, carbonates help form structures that are hardy enough to survive in fossil form for billions of years, including seashells, corals, and some stromatolites. They're rocks formed by microbial life along ancient seashores, where sunlight and water are plentiful. The possibility of stromatolite structures existing on Mars is why the concentration of carbonates tracing JEZERO's shoreline like a bathtub ring makes the area a prime scientific hunting ground. Mars 2020's primary mission is a focus on astrobiology. Equipped with a new suite of scientific instruments, it aims to build on the discoveries of Curiosity, which has been studying Gale Crater and found that the region could have supported life billions of years ago. Mars 2020 will go one step further and look for actual signs of past microbial life, taking rock core samples that will be deposited in metal tubes on the Martian surface. Future missions to Mars will then collect and return these samples to Earth for deeper study. In addition to preserving signs of ancient life, carbonates can teach scientists more about how Mars transitioned from having lots of liquid water and a warm, thicker atmosphere to becoming the freeze-dried desert it is today. Carbonate minerals form from interactions between carbon dioxide and water, recording subtle changes in these interactions over time. In that sense, they're like time capsules which scientists can study to learn when and how the red planet began drying out. The 45-kilometre wide JEZERO crater was also once home to an ancient river delta. The arms of this delta can be clearly seen reaching across the crater floor in images taken by NASA's Mars Reconnaissance Orbiter. Now, that doesn't guarantee that shoreline carbonates were formed in the lake. They could just as easily have been deposited before the lake was present. But their identification makes the site's western rim, known as the marginal carbonate-bearing region, one of the richest troves of these minerals anywhere in the crater. The Mars 2020 team expect to explore both the crater floor and the delta during the rover's 2-year primary mission. And JEZERO's former lakeshore isn't the only place scientists are excited to visit. A new study in the Geophysical Research Letters points to a rich deposit of hydrated silica on the edge of the ancient river delta. And like carbonates, here on Earth at least, these minerals excel in preserving signs of ancient life. And if this location proves to be the bottom layer of the delta, it'll be an especially good place to go looking for buried microbial fossils. Who knows what they'll dig up? You're listening to SpaceTime. Still to come, NASA looking at a new mission to orbit Pluto, and it's taken over 30 years and some of the most remote deserts in Australia, but astronomers have uncovered some of the deepest secrets of Supernova 1987A. All that and more still to come on SpaceTime. The European Space Agency is planning a new mission to study a comet. The Comet Interceptor mission will follow on from the Rosetta spacecraft mission, which spent 2 years studying the comet 67P Churyumov-Gerasimenko. 67P is a Jupiter family comet which orbits the Sun every 6.45 Earth years. It originated in the Kuiper Belt, the ring of comets, icy debris and frozen worlds circling the Sun out beyond the orbit of Neptune. Eventually, it was knocked out of the Kuiper Belt and ventured into the inner solar system. only to be caught by Jupiter and sent on an eternal orbit around the Sun. Rosetta discovered that the 6.5-kilometre wide comet contained oxygen, organic molecules, noble gases, and heavy or deteriorated water, which is different from most of the water found here on Earth. Through its discoveries, Rosetta's provided scientists with fresh insights into the origins of the solar system and how planets are made. And ESA's future Comet Interceptor mission will build on Rosetta's successes when it performs a flyby of a comet. But unlike Rosetta and Giotto, which visited Comet Halley in 1986, this mission will target a pristine comet, one which has never ventured into the inner solar system before, and therefore hasn't been affected by the Sun. Comet Interceptor will comprise 3 spacecraft, which will travel to the Lagrangian L2 position, where it will wait for a suitable target. The L2 position is a point in space where the gravitational effects of the Earth and the Sun cancel each other out. It's on the direct other side to the Earth from where the Sun is, and it's a gravitationally neutral location, allowing spacecraft located there to remain in that position relative to the Earth for extended periods of time without needing to use up their fuel supplies. Then, once a target comet's found, the spacecraft will travel towards the target before the 3 modules separate a few weeks prior to intercepting the comet. Each module will be equipped with a complementary scientific payload, providing different perspectives of the comet's nucleus and its gas, dust and plasma environment. The mission's instrument suite will draw on heritage from other missions, including a camera based on the one currently flying on the ExoMars Trace Gas Orbiter, along with dust, fields and plasma instruments, as well as a mass spectrometer like those that flew on Rosetta. This report from ESA TV.
The Rosetta mission is the gift that keeps on giving. Scientists are still analysing data from its instruments and delivering data to an archive as a resource for the future. This includes data on Comet 67P's diverse landscape, coma and plasma, the ionised gas coming off the comet.
Regarding the plasma, I think we were very surprised how different Comet 67P and its environment is from all the comets that we have visited before. So basically what we are looking at with the plasma is an interaction between the solar wind, which is a magnetic field and charged particles, and the charged particles that are developing around the comet, right? So you start off with a neutral gas and you ionize it, and these particles interact with the solar wind. From our previous experiences, the number of particles was very high. But with Rosetta, it actually wasn't. So I think the biggest surprise was that basically a lot of our predictions were wrong. But this is good because then the data tells us, okay, maybe you're missing something. You missed including this process in your models. And now we've had the time to actually include these processes in our models and improve our science that we get out of it. And I think that was the most fun part as well about doing the science with Rosetta.
The Rosetta instrument, a spectrometer for ion and neutral analysis, examined the composition of the comet's atmosphere and ionosphere and investigated the gases coming off the comet. It discovered organic molecules and a complex form of carbon in a series of important findings.
The first one was the deuterated water. So we showed that the terrestrial water cannot come, at least the bulk of the terrestrial water cannot come from comets. Then it's certainly the oxygen, the O2, which was completely unexpected and which points to a primordial origin in pre-solar of O2 and probably many other species as well. Then we have found the noble gases, especially xenon isotopes, which tell us that probably the terrestrial atmosphere got some cometary material because the xenon in the comet and our atmosphere are similar. And from that we can calculate how many comets probably hit the Earth and how much organics were brought by comets to the Earth. And that's a lot. It's really a whole lot of organics. And this could have sparked life on Earth.
Comet 67P orbits the Sun every 6.5 years, so it will be observed again from Earth in late 2021. And this led scientists to consider something new.
What this inspired us to think about is about how can we see how can we really get a pristine comet? How can we see what the comet looks like before it meets the Sun? And that's led us to talk about this, to propose this new mission, which we now have Comet Interceptor, which is a different type of mission entirely from Rosetta. It is a fast flyby mission, so we don't orbit the comet, we don't stay and follow it. We encounter a comet at high speed, fly past it, and get all of the data we can in only a few hours.
Comet Interceptor will target a new comet that has never entered our solar system before. It could also examine something like Oumuamua. Discovered in 2017, it is the first known interstellar object to have visited our solar system. And so Rosetta's ongoing legacy will inspire yet more scientific discoveries in the future.
And that report from ESA TV included ESA research fellow Carla Goetz, Rosetta's Rosina instrument scientist Catherine Altweg from the University of Bern, and the principal investigator for the proposed ESA Comet Interceptor mission, Colin Snodgrass. You're listening to SpaceTime. Still to come, NASA launches its Ikon satellite to study the ionosphere, and later in the science report, the first evidence of feathered polar dinosaurs in Australia. All that and more coming up on SpaceTime. Well, speaking of planned missions, NASA's just funded the Southwest Research Institute in Boulder, Colorado, to study the important attributes, feasibility and cost of a possible future Pluto orbiter mission. The study will develop a spacecraft and payload design requirements and make preliminary costs and risk assessments for new technologies. The proposal is one of 10 different mission studies that NASA is sponsoring to prepare for the next Planetary Science Decadal Survey. Of course, the Southwest Research Institute led the New Horizons mission, which flew to Pluto and its system of moons, and then onto the Kuiper Belt object 2014 MU69 Ultima Thule, the furthest and most primordial object ever visited. New Horizons has been returning data that's made a compelling case for a follow-up mission to Pluto. The Southwest Research Institute's Dr. Carly Howard says the mission concept at this stage is to send a single spacecraft to orbit Pluto for about 2 Earth years before breaking away to visit at least one Kuiper Belt object and another Kuiper Belt object dwarf planet. Despite all that New Horizons revealed about the Pluto system and the Kuiper Belt, it could really only get a snapshot of Pluto, its binary partner Charon, and their 4 moons Styx, Nix, Kerberos and Hydra. Additionally, New Horizons only carried a limited payload of scientific instruments, and many aspects of Kuiper Belt object and dwarf planet science require different kinds of instrumentation and the kind of global and temporal coverage that really only an orbiter can provide. A Pluto orbiter mission would be designed to answer some of the many questions that New Horizons' discoveries have sparked. New Horizons principal investigator Dr. Alan Stern, also from the Southwest Research Institute, says a study has already shown that a Pluto system orbital tour mission was feasible with planned capability launch vehicles and existing ion electric propulsion systems. That study also showed that it would be possible to use gravity assists from Charon to escape Pluto orbit, go back into the Kuiper Belt for the exploration of more Kuiper Belt objects such as MU69, and at least one more dwarf planet for comparison to Pluto. New Horizons was launched back on January the 19th, 2006 from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The probe made history on July the 14th, 2015, when it became the first spacecraft to visit Pluto, flying just 12,500 kilometers above the 2,377 kilometer wide dwarf planet's surface. New Horizons' next encounter was on January the 1st, 2019, when it undertook a close flyby of the 30-kilometer wide Kuiper Belt object 2014 MU69 Ultima Thule. Ultima Thule is an ancient traditional name used to describe the most distant place known, a land well beyond the borders of the known world. Back in Greek and ancient Roman times, Ultima Thule was the place most furthest north, now thought to refer to Iceland or Greenland, although both the Orkney and Shetland Islands have also been referred to as Ultima Thule in medieval times. However, although appropriate, Ultima Thule was only ever a nickname. Now a proposal has been made to officially name MU69 Arakoth, a Native American term meaning sky in the Powhatan Algonquin language. The proposal has now been submitted to the International Astronomical Union and the Minor Planet Center, the official international authority for naming Kuiper Belt objects. You're listening to SpaceTime. Still to come, Hayabusa 2 on its way back home after completing a 1.5-year-long mission studying the near-Earth asteroid Ryugu. And later in the science report, a new study finds people who tend to believe in conspiracy theories are often very lonely. No surprises there, I guess. All that and more still to come on SpaceTime. It took over 30 years and some of the most remote deserts in Australia for astronomers to uncover some of the deepest secrets of supernova 1987A. The observations have shown that the nearest supernova in over 400 years had far slower than expected stellar winds just before its death throes. Supernova 1987A marked the explosive destruction of a spectral type B3 blue supergiant star called Sanderlik -69202 on the outskirts of the Tarantula Nebula, some 168,000 light-years away in the Large Magellanic Cloud, a dwarf galaxy orbiting the Milky Way. Sanderlik -69202 is estimated to have been at least 20 times the mass of our Sun. The discovery that a blue supergiant was a supernova progenitor contradicted all known theories at the time and produced a flurry of new ideas about how such a thing might happen. 1987A was the first supernova that modern astronomers were able to study in great detail, providing science with new insights into core collapse Type II supernovae. While much has been learnt about the immediate past of the explosion and history of the progenitor star by studying its cosmic ruins, major gaps in science's understanding of this event remain. SN 1987A provided the first opportunity to confirm by direct observation the radioactive source of the energy for visible light emissions by detecting predicted gamma-ray radiation from two of its abundant radioactive nuclei. This proved the radioactive nature of the long-duration post-explosion glow of supernovae. Approximately 2 to 3 hours before the visible light from 1987A reached Earth, a burst of neutrinos was observed. This was likely due to neutrino emission, which occurs simultaneously with core collapse, but before the visible light is emitted, the visible light being transmitted only after the supernova shockwave reaches the stellar surface. Based on the mass of the progenitor star, 1987A should have produced a super-dense compact stellar corpse called a neutron star. And the neutrino data suggests that a compact object did form at the star's core. The problem is astronomers have so far at least been unable to find it. The data about its stellar winds was uncovered by the Murchison Widefield array in outback Western Australia. The array picked up the faintest of low-frequency radio hisses, which allowed astronomers to see right back to when the star was still in its red supergiant phase. The research, reported in the monthly notice of the Royal Astronomical Society, was led by the University of Sydney's Joseph Callingham. Callingham and colleagues were able to observe 1987A at some of the lowest radio frequencies ever observed. The key to gaining these new insights was the extreme radio-quiet outback desert environment in which the radio telescope's located. Prior to this, nobody really knew what was happening at low radio frequencies. That's because signals from earthbound FM radios drown out the faint signals from space. But by using the Murchison Widefield array to study the strength of the radio signal, astronomers were for the first time able to calculate just how dense the surrounding gas was, and thus understand the environment of the star before it died. Those results have helped fine-tune science's understanding of these stellar explosions, and the research paints a picture of the star's life long before its spectacular death. Previously, only a fraction of the dead star's multi-million-year-long life, about 0.1% or 20,000 years, had been observable. But the new observations using Murchison enabled astrophysicists to probe the supernova's past life millions of years further back than previously possible. Callingham says previous studies had focused on material that had been ejected into space when the star was in its blue supergiant phase. He says, just like excavating and studying ancient archaeological ruins, which teach us about the life of past civilizations, the Murchison Widefield Array's low-frequency radio observations provide a window into the star's life. As the star reached the end of its life and ran out of hydrogen for core nuclear fusion, a thing which makes stars shine, it began fusing heavier and heavier elements at hotter and hotter temperatures in its core, causing its outer layers to expand away from the core, and being further away, they began to cool, turning the star from a hot blue supergiant into a cooler red supergiant. Eventually, the star produced iron in its core, which couldn't fuse into anything heavier, and so the star collapsed, causing a supernova, an explosion so bright it briefly outshone the entire galaxy and was easily seen from Earth. The authors found that during its red supergiant phase, it lost matter at a slower rate and generated slower stellar winds that pushed into the surrounding environment than what was previously assumed. The findings improved science's knowledge of the composition of the space in the regions surrounding supernova 1987A. Cunningham says the data's allowed astronomers to go back to the simulations and tweak them to better reconstruct the physics of supernova explosions.
So we've been looking at 1987A at really low radio frequencies, so essentially frequencies you tune your FM radio to, so like 105 megahertz or something like that. And in particular, what we're interested in is the phase of the star's life before it went supernova. And so in particular, my study was very sensitive to the star when it's what's called its red supergiant phase. And that's this phase that our sun will actually kind of go through, where essentially it's run out of hydrogen in its core and it's moved to helium burning in its core, and the outer layers expand up and become red and fluffy and cooler.
You used the Murchison Widefield array. That's a different type of radio telescope, isn't it?
Yeah, so the Murchison Widefield array is based out in Western Australia, in the Murchison Shire, funnily enough. And it works, as I said, really low radio frequency, so essentially sensitive between 72 and 230 megahertz. This is a precursor to what's called the square kilometre array, so essentially a big radio telescope that the community is invested in building, and it's designed to kind of test the engineering and the science capabilities of that. And so as a precursor instrument, as I said, 72 to 230 megahertz, and that's equivalent to when you get in your car and you tune your radio to 105.5 star FM. You're picking up essentially the frequencies that I'm sensitive to in the Murchison Widefield array. But instead of spending all this money to build essentially something that's sensitive just to radio, we build it really far away from people to get away from interference. And so we're sensitive to astronomical objects, and just one of them happens to be 1987A.
And 1987A is an amazing supernova. It was one that sparked my interest in astronomy, and it's a bit unusual from a supernova because of the way it's evolved.
Yeah, so it's the closest and brightest supernova to occur since the invention of the telescope, which is kind of amazing to think about. So you can essentially take the telescope was first pointed to the skies by Galileo in about 1600. So not to have a supernova go off except 1987A is pretty crazy, and it just goes to show how important this object is to our understanding of how massive stars and their lives. What we know about the progenitor is it's kind of odder than we ever thought or ever predicted. So the star that actually did go into supernova, all our theories kind of predicted you'd be like if you're about 5 times more massive than the sun, you'll go through kind of a sun-like phase, and then you'd enter this what's called the red supergiant phase, which I described before, and then you'd eventually supernova. But what we found by looking at archival information of the galaxy at which 87A exploded in, called the Large Magellanic Cloud, we realized that the star actually went through a blue supergiant phase before it exploded, which is kind of odd. We never expected that at all. So why and how is questions that we've been trying to answer.
Red and blue, that's got a lot to do with the temperature of the star itself, doesn't it?
Yes. So red of the star, I know it's kind of funny because in everyday life, we usually mean red to be warm or hot. But for a star, red is actually as cold as you pretty much get. Red is quite a cool star, while blue represents hot. And so your listeners might remember from high school the Bunsen burner. And in particular, they might remember the red safety flame. But if you wanted to use a Bunsen burner, you always turned it on, and the hottest part of the flame was always the blue part of the flame. And this has got to do with black body radiation, but it's not important exactly what it is. It's just the bluer, the hotter, and redder, the cooler. Kind of counterintuitive what we're kind of taught and what we use in everyday language. We're not quite sure why it went through a blue supergiant phase, and so it's quite hard to figure out and exactly why we saw a blue supergiant before it collapsed. So some thoughts have been maybe it was a binary star system. So there's 2 stars that existed in the system, and one evolved to a red supergiant star. And there might have been something like the sun next to it. And for some reason they merged, they fused together. And in that process, that's quite violent. And that caused it to heat back up and go into this blue supergiant phase again. But it's possible that's maybe not the case at all. Maybe it went through a really weird mass loss scenario. So the star, for some particular reason, lost heaps and heaps and heaps of mass. And so it spewed out and it became blue supergiant again. It was all very odd, and we never expected that at all. And so I can't really tell you the final answer, the reason why it entered the blue supergiant phase, but we know it did. And so we have to change our theories to understand that.
Because 1987A has such a weird hourglass shape, it's not an expanded spherical type shape, it's hourglass. Could that be telling us something?
Yeah, so the morphology of the supernova remnant is even odd for us, right? So again, we kind of think most supernovae would be roughly spherical, right? You explode a star, it should go out equally in all directions. But for supernova 1987A, as you said, we see this hourglass shape. So it seems tighter at the waist, and then it kind of expands in these 2 rings at the ends. And so people hypothesized maybe that's why, maybe it had to be a binary, right? For example, the binary merged on the equator, and so that's why you have a tight waist, and a lot of the mass loss occurred at the poles. But you also can get that shape if you have a really fast spinning star, a star that's spinning really quickly, and you get a lot of the ejection from the poles rather than the equator. And so, or I mean, a lot from the equator as well, from the poles. So it's a very odd shape, and just goes to show 87A is still revolutionizing our way we understand about massive stars and their lives and how supernovae occur.
A spin-up caused by an increase in mass by two stars merging sounds feasible, doesn't it?
Yeah, it's a possibility, and there's been simulations here, and it's one of those questions I don't know if we'll ever know the answer to. We can get close, and there's good suggestions for one or the other, but I don't know if we'll ever know the exact true answer there. What exactly caused it to go to a blue supergiant phase?
That's Joseph Cullingham from the University of Sydney. And this is Space Time. I'm Stuart Gary. NASA's Ionospheric Connection Explorer satellite Ikon has been successfully launched into orbit on a mission to study the ionosphere and how space weather from above impacts the Earth's atmosphere and terrestrial weather from below. Ikon was launched aboard a Northrop Grumman Pegasus XL rocket, which was carried to an altitude of 11,900 metres or 39,000 feet, mounted on the underbelly of a Lockheed L-1011 TriStar airliner, which had taken off from the Cape Canaveral Air Force Station in Florida.
3, 2, 1, drop. Pegasus away. Vehicle is fully armed. Stage 1 ignition has been confirmed.
Launching Ikon to explore and unlock the mysteries of the weather where Earth meets space.
Through transonic. Power buses remain strong. Stage 1 fin actuator system is operating nominally and controlling the aerodynamic flight of the vehicle. Coming up on 30 seconds into the Ikon mission. Vehicle has passed through max Q. Attitude remains nominal. All power buses nominal. All vehicle subsystems are operating as expected. Stage 1 burnout in approximately 20 seconds. Stage 1 has burned out. Attitude and the flight path are nominal. Approximately 10 seconds until Stage 1 separation. Stage 1 separation confirmed. Stage 2 ignition has been confirmed and attitude is nominal. Stage 2 TVC is operating as expected to control the flight of the vehicle. Approximately 20 seconds until fairing jettison. Fairing deployment has been confirmed. Both halves have been separated. Vehicle attitude remains nominal after fairing separation.
The mission had been delayed multiple times over 2 years because of ongoing problems with the Pegasus rocket. Space weather, also known as geomagnetic storms or solar storms, occur when energetic particles are blown out of the sun by events such as solar flares and coronal mass ejections. These are triggered by magnetic activity on the sun, flinging energy and ionized particles into space. If these charged streams of plasma reach the Earth, they trigger auroral activity as the high-energy charged particles, usually protons and electrons, collide with the Earth's magnetosphere and are guided by the planet's magnetic field lines through its ionosphere, another region of charged particles. As these particles travel towards the north and south magnetic poles, they collide with oxygen and nitrogen atoms and molecules in the Earth's upper atmosphere, causing them to excite and emit photons, giving off a glow and producing colourful curtain-like displays known as the northern and southern lights, the aurora borealis and aurora australis. The colours being emitted in these auroral displays depends on which particles are being ionized. Reddish brown glows are caused by the collision of these particles with single oxygen atoms in the Earth's upper atmosphere, usually above 300 kilometres. Lower down are green hues created by single oxygen atoms down to altitudes of around 100 kilometres. The kaleidoscope then turns a whitish yellow beige when nitrogen is mixed with the oxygen. Aurorae also exhibit a blue, red or even purple glow in the lower atmosphere. That's caused by the excitation of molecular nitrogen below 100 kilometres. However, as well as the spectacular auroral light shows, these charged particles also cause far more sinister events, such as the damage or destruction of spacecraft. On the ground, they can overload power lines, causing widespread blackouts. Space weather also affects communications and navigation systems, forces polar airline flights to be rerouted to lower latitudes using more fuel, and causes thicker layers of the Earth's atmosphere to expand outwards, increasing atmospheric drag on spacecraft, resulting in premature orbital decay. And worse still, space weather increases the radiation exposure astronauts experience, affecting their health. Ikon's 2-year mission will study how space weather changes this region of the upper atmosphere from its 360-kilometre high orbit. Historically, this critical region of near-Earth space has been difficult to observe because spacecraft can't travel through the lower parts of the ionosphere, and balloons simply can't get high enough. Ikon will help scientists understand this dynamic space environment by simultaneously tracking what's happening in the Earth's upper atmosphere and in space to see how the two interact. The 287-kilogram spacecraft is equipped with 4 instruments: a Murchison interferometer to measure winds and temperatures in the thermosphere, an ion drift meter to measure the motions of charged particles in the ionosphere, and 2 ultraviolet imagers to observe the airglow layers of the upper atmosphere in order to determine both ionospheric and thermospheric density and composition. Like aurorae, airglow are created as atmospheric molecules and atoms are excited by radiation from the sun and emit photons. But while aurorae are bright but usually confined to higher latitudes, airglow happens constantly right across the globe. But the thing is, it's far fainter. And that's where Ikon comes in. Its instruments will build up a picture of the ionosphere's density, composition and structure by observing this airglow and seeing how particles are moving. You're listening to SpaceTime. Japan's Hayabusa 2 mission is on its way back home after spending the last year and a half studying the near-Earth asteroid Ryugu. The Japan Aerospace Exploration Agency JAXA undertook a series of risky and unprecedented maneuvers, gently firing Hayabusa 2's thrusters to move it away from the kilometre-wide asteroid. Early next month, the probe will switch on its ion engine and begin its 300 million kilometre journey back to Earth. It's due to swoop past Earth in December 2020, where it will jettison a small re-entry sample return capsule that will parachute down to a landing in the Woomera rocket range in outback South Australia. The samples will provide scientists with carbon and organic matter that will help explain the evolution of terrestrial planetary bodies in the solar system. Hayabusa 2 was launched back in 2014, arriving at Ryugu in June 2018. It's the first mission to release landers onto the surface of an asteroid. It's also the first probe to collect samples from a so-called dark asteroid surface. Astronomers think the asteroid's dark because of having such a high concentration of carbon. And Hayabusa 2 was also the first spacecraft to successfully fire a projectile into the surface of an asteroid to create a crater to collect a sample of subsurface asteroidal material. Ryugu was found to have a surprisingly low density. That suggests it's a rubble pile asteroid made up of small rocks loosely bound together by gravity. Its surface is strewn by more boulders per unit surface area than any asteroid explored so far. Scientists believe Ryugu was formed from debris from the impact between 2 larger asteroids millions of years ago. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. New research has found growing evidence that vaping may harm the heart and circulatory system. A study in the journal Cardiovascular Research compiled the available data on the health effects of e-cigarettes, finding proof of harmful effects on the heart and blood vessels is accumulating. The authors warned that as most of the studies they looked at only considered the short-term effects of vaping, longer-term effects may be even more severe, and the public simply shouldn't assume that vaping is a safe alternative to smoking. Meanwhile, a separate study warns that people should consider e-cigarettes safer than tobacco at their own peril. The warning follows the treatment of a teenage boy with life-threatening lung failure linked to vaping. The boy, who had no history of asthma, developed a case of hypersensitivity pneumonitis, where the air sacs and airways of the lungs become severely inflamed, which led to a month-long hospital stay and lengthy rehabilitation. A report in the journal Archives of Disease in Childhood found that the teen had recently taken up vaping and got worse when doctors tested his skin reactivity with vaping fluid, leading doctors to believe that one of the chemicals in the e-cigarette fluid was triggering an intense immune response. Facebook software has been caught covertly activating iPhone users' cameras as they scroll through Facebook news feeds. Facebook claims the glitch was caused by a coding error and that there was no indication that any of the photos or videos had been sent to its servers. The tech giant says version 244 of the Facebook iOS app would incorrectly launch in landscape mode, and it's already sent a fix to Apple. For now, the bug isn't affecting Android devices and appears to be exclusive to iPhone users running iOS 13. As a workaround, we recommend you revoke camera and microphone access to the Facebook app in your iOS settings. Paleontologists have discovered the first evidence of feathered polar dinosaurs in Australia. Scientists uncovered the cache of 118 million-year-old fossilised dinosaur and bird feathers in a deposit known as the Coonwarra fish beds, 145 kilometres southeast of Melbourne. The site was once an ancient shallow lake bed, originally situated south of the Antarctic Circle. Researchers analysed a collection of 10 fossil feathers. They displayed an unexpected diversity of tufted hair-like proto-feathers from meat-eating theropod dinosaurs, together with downy body feathers and wing feathers from early avian birds, which would have been used for flight. The unique discovery is highly significant because they came from dinosaurs and small birds that had survived in a seasonally very cold environment with months of polar darkness every year. Researchers say fossil feathers had been recovered from the site previously and were thought to be evidence of ancient birds, but had received little scientific attention. The new study by scientists from the Pavel Yosef Safarik University, Monash University, the Melbourne Museum, Uppsala University and the Swinburne University of Technology examined both newly discovered and existing feathered fossils. They found the dinosaur proto-feathers would have been used for insulation in the ancient polar habitat. The authors also detected microscopic remains of cellular structures thought to have contained colour pigments, suggesting both uniformly dark feather surfaces on some dinosaurs and distinct bands that might represent original patterning on others. The International Atomic Energy Agency has warned that Iran has begun enriching uranium at its secret Fordow underground nuclear facility in breach of its United Nations nuclear agreements. Tehran had earlier transported uranium hexafluoride gas to the facility and connected the supply to 2 cascades of advanced centrifuges, also in breach of its UN obligations. The report says the move will allow Tehran to continue growing its enriched uranium stockpile. It's now estimated the Islamic Republic would have enough enriched uranium within a year for a nuclear weapon. However, the oil-rich nation insists its nuclear program is for peaceful power generation only. A new study has found that people who tend to believe in conspiracy theories are also often very lonely. The findings, reported in the journal PLOS ONE, are based on a study of the language used by Reddit users on conspiracy forums such as Our Conspiracy, compared to other users who don't interact with these forums. Researchers found that while conspiracy theorists weren't hostile, they were less likely to use tones related to categories such as affection, optimism, and friends, indicating they may be more alienated or socially isolated. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the Spacetime with Stuart Gary YouTube channel. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.